Okay guys, let's take a look at our lesson for today. We're going to be looking at arc length. We're going to learn a formula and find out how to find the measure of arc length. Now before today, probably when we hear the word arc length, we might think of, perhaps with respect to a circle. We've talked about arc lengths with respect to circles before. This really is a much more general concept of arc length. What it's going to allow us to do is actually find the length of a curve, of a section of a curve. So if, for example, we had, say the parent parabola, and for some reason, we wanted to find the length of this portion of the curve, we would be able to do that with this formula, with this arc length formula. We actually will be finding arc lengths of other things like parametric curves and polar curves and things, but this is the formula for arc length of a function, like x squared, or some kind of a function that we're familiar with, square root of x. So this formula, it's pretty straightforward. L stands for, it's the typical letter that's used to designate an arc length. That's just, normally they call it L. Not always, but many textbooks like to use capital L. So to find the arc length is going to be equal to the bounds, either the starting and ending of the section of the arc length that I want to measure, of the curve that I want to measure, square root of 1 plus the derivative, the first derivative squared dx. I mean, that's all it is. That's just a formula. So integral from a to b of square root of 1 plus f prime of x squared. The textbook that I got this out of felt that it was really important to write them, with the different types of notation, f prime or dy dx. Doesn't really matter. We know that it means the same thing. You can also calculate arc length with respect to y, and this is just the version with respect to y. So it's just a basic formula. We have a couple of examples that we're going to do, just 2 of them. We're also going to continue using our calculator in order to find these integrals. Now, you will certainly be expected to do this type of things without a calculator on the test, but when we first learn this, I think it's really important for us to practice it as much as possible. We can do that if we use the calculator to help us with the number crunching part. So let's do the first one. We've got to remember to find the derivative. That, I would say, one of the most common errors that I see on finding arc length is, especially with trig functions, we forget to find the derivative and we just stick the original function in there. Of course, it's not going to work properly. So we need to be sure to find the derivative. So let's do that. So this would give us 3/2 x to the 1/2. So our arc length, they want us to measure from 0 to 4, square root of 1 plus my derivative squared, which is 3/2 x to the 1/2 squared dx. I put that in my calculator and I get my arc length to be 9.073. 9.073. So pretty straightforward. There's really nothing more to it than this. It's just finding the derivative, putting it inside the radical. Now I will tell you, doing these by hand can sometimes be pretty challenging because you're left with just a radical with sometimes some crazy stuff underneath. But the next unit that we're going to be going into is actually integration techniques. So we're going to learn all kinds of different and fun integration techniques to add to our skill set. Alright, so let's take a look at our next one. We need to find the derivative, so y prime is going to be, let's see, 2x to the negative 1/3. And so we utilize our formula, arc length equals integral from 8 to 27, square root of 1 plus our first derivative squared, and we get, again using our calculator, 24.245. And that's really all there is on the lesson today, is this additional technique for arc length. Our daily work is going to have several arc length problems that we're going to be working, plus some review problems of area and volume. So any questions on the arc length technique. Are we okay with it? It's pretty straightforward, especially when we get to use a calculator. Okay?